Well, what up, and welcome back to the fourth part of the snake tutorial in ARM64 assembly, the Easter special. And last time we managed to make the he has to wake up. It's a warm day, so I don't know. Okay, last time we managed to make the snake to move. So this time it's time to place food on the table and make the snake grow. One thing we forgot last time was to have enable raw mode, which we are going to do very fast here at the beginning, and then we're gonna get right into making the snake grow and placing the food on the table. The last green juice here from Motto juice bar, best in Manhattan, with a lot of ginger. So doesn't matter. Let's go to the raw function here, enable raw mode. And the only thing, we already copied and stored everything, but at the end I forgot it. So all I'm going to do is I'm going to copy all of this here, right, where we are setting the raw mode, going down here and paste it. And I have to get used to this now, and enable raw mode. And now we're going to call this and enable cooked mode. And enable raw mode. I have to be careful now. And enable raw mode. Where's the return here? Yeah, I have to be a little bit careful what I'm doing here. And enable raw mode. That return is necessary. So careful. And now we're gonna call this function enable. Did I start recording? Yes. 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 My God. Enable cooked mode. Do our function stuff. So LDP FP LR in stack pointer no -16, and then move. Oh no. Okay, 1 second. I have to get used to it. The stack pointer in the frame pointer. And have this. So now here we loaded in X2 the raw struct, and what we're going to do now is simply taking address page X2. What do we call it? Termius cooked, I think. Termius cooked at page. Let me check if the name's correct. That looks fine. So we're gonna add X2 X. Oh, I should just do this. Change that X2 X2 X2, and we're gonna call this page off. So if you remember the TC get and TC set, when TC set, the terminus is in the last argument. So this is why we do this. So let's check that, and of course FLDPS, this is this comma issue. I think so. This is also wrong because we are storing, store here, load there. So this is this, and there is a comma missing. I'm gonna creep that. And enable raw mode is already. And enable raw mode. And didn't I change the name? Change till this. Cooked mode, obviously. Alright, that works, but we don't know if the function works. So I'm gonna take it. We're gonna go to raw mode here, and we're gonna place it right here. So now we have a Segfault. Enable raw mode. That's not good. Store FPL on 16. Move the stack pointer in the frame pointer. Load it. So address p terminus cooked 01. And are we returning? No way. Okay. LLDB snake. And allow. What? Run it. Backtrack. Okay, that's a little weird. So enable cooked mode. So let's take that out for a second. Again. So the error is obviously there. So 1 second here. Let me stack pointer FPLR SP. Oh, of course. Welcome to arm64. Okay, now I have to press and we're gonna move forward. All of this works. And if I comment this out here, this should work again. So these two functions obviously like they should negate each other. So now we can move it. And that's not for here, this is actually for the end. But for now I'm just exiting with Control Z. So we're not really exiting on that code path, but at the end we will. So we have this set up to leave no trace at the end. Alright, so far so good. So the next thing is we're gonna need to create a random number, we need to seed it, and once we have it, we need to put the food on the table. So let's get started, because there's still a lot to do. We're going to start with get time of day. That's the first function we're going to write today. And okay, let me, I always had my welcome to arm64 moment for today. So, welcome, welcome. We're gonna do FPSP, and then here SP, and I don't know what I have here from the tree. FPSP, and then LDP, FPLR, SP, and move the stack pointer away. So, do we need a comma here? Place a comma here, and then we're gonna return. Get time of day. Yes. Tell me you want a colon. That's all I want to hear from you. Okay. So get time of day is actually just a syscall that, and I said this before, if I had uploaded the 10 videos, this would not be in it. So. But it will be on the GitHub in the README. So this here is the syscall is time of day. The number is 116, and all it does is provide the seconds for the Unix epoch and some milliseconds. And the 48 here is incorrect, how I figured out today. So we're gonna do first and foremost, go here and create whatever time of day struct, and we're gonna need, this is gonna need, I think 16 bytes was enough, so we're gonna use time of day 16. We're gonna load the address page x0 time of day at page, do some jacking here, and add x0 with a page off. So now we have the address. Actually, we should check in what register we need that, and that's x0. Okay, then we need a null in x1. So we move 0 in x1. We have this one. Is there anything else? REX, no, x16 needs the 116. So move x16. We're gonna call this sys time of day. Invert. So let's go to the other syscalls. And I'm just gonna place this right about here. And this was 116. 100. This is the decimal number. I hope that works. Why am I placing this here? So we have this here. Let's run it. Time of day, token in argument list, time of day. Next one, a comma after the second 0 right here. So okay, we are still running, so this should be the syscall. So let's go, and we are not needing our snake field here, so I'm gonna comment all of this out for now, and all I'm gonna do is get time of the day. I wrote it, so now I'm gonna make it. I just saved, right? So we have this. So let us go slowly today, not slowly but steadily. Investigate. Oh, this is extremely important. Actually, we will maybe see in a moment why. So let's go here. Register read x0. We have a 1. Register read x0 has a 1. Oh, I didn't add yet. Is this possible? Register read x0. CLS. Okay, now, okay, I'm ahead of the curve here. Register read x0. Now we have time of day. So we are going to take it x64 xp, and there are a bunch of zeros, so, and they will stay there because we didn't do the syscall. So let's correct that here. Supervised call 0x80. Let's make it object dump. No, this should still work. No, it is down one line probably. Break. Okay, we are here, back in. So let us check the address again. So here's still a 0. Register read x0. Is it still the 93? It is. So we are setting up the syscall. Now we're doing the syscall, and we are good. There has to be, this syscall has to be 16 aligned. Otherwise it doesn't work. But at the moment it's working. We have here the seconds from January 1st, 1970, the Unix epoch, and here some milliseconds. And this value is basically what we're going to use now for what we're going to use to set up our pseudo random number. All right, so I have no touch bar now, so first function's down. 15 minutes, first function down. So I changed this right here on the spot. We're now going to do seed random number. We're going to create a seed random number. And all I'm going to do here is, let me do it one step here at a time. Bang, move FP SP, and then have this right here. LR, stack pointer, top 16. So the next thing we're going to do is we're just going to take the first 8 bytes and copy them in something that we call random number, so that we have there our random number that we're always going to generate and store back in memory. So let us go to time of day and create here a random number. This is going to be 8 bytes because it's just the first row of the time of day struct. So seed random number. And now we're going to use our copy struct function, and we are simply going to address page x0 time of day at page, and then let me get 30 jank. We have time of day. I'm going to copy this, replace the 0 with a 1, and change invert random number, and the same here. So now we have time of day in x0, the address of random number in x1, and all we need to remain is the in x2 the size. So we're going to move 0x8 into x2. That's the wrong direction, so it's going to be like this. And then we're just going to do branch label copy struct. Address page, time of day. Address page. Yes, we meant this. So we're gonna have, we have here somewhere, we have the get time of day, and now we're gonna seed random number. Seed random number, and like always we check it now. Object dump minus the snake. And wherever we are, right about here, enable cooked mode, no get time of day, no, we want to seed the random number. So there we are, seed random number, LLDB snake, break set minus address, and here we are. So let us check out the memory. There's our, we already called get time of day. So this is here. So this line we are looking now to copy. So I'm going to go to seed random number. Everything is here. Register read x1. This address register read x2. No, x0. Register read x0 is the time of day, but we want to check out this, but I suspect it's right next to I don't suspect, we know it's right next to. Actually, let's go here. And this random number should appear here. So where's our, did I press next? And copy struct loop, that's what I wanted to avoid. So let's go here. Let's copy break set address. We're gonna continue, and this should finish it. And here we have our copied new random number, or our seed. All right, that's good. So we're gonna quit this. So now we're gonna implement this thing here. Where is it? This is the, whatever it's called, I always forget, the linear congruential generator, so an LCG. And all it does is it takes a number, that's gonna be our seeded number, multiplies it with well-established constants from GCC and the CLib. This is taken right out of Wikipedia. We're going to implement this function, and that's all we're going to do. So, without further ado, let's keep it moving here. Time of day. Where are we? Seed random number. I don't know how I named the function. I know that more or less because I just did it for the x86, but I don't know because the battery there is empty. We have no nodes. So we're gonna do generate pseudo random number. I think that's right. We're gonna call this, got a colon, and end it. Stack f, no comma here, fplr sp minus 16. I'm gonna move frame pointer, stack pointer, and we're gonna move stack pointer, frame pointer, ldp fplr sp 16. We're gonna return. The first thing we need is obviously our seed, so we're gonna use our random number. And can I copy this? I don't see it, so we're gonna just type it out real fast. x0 in random number, add page, and we're gonna add a random number to page off. So now we have the address. I want to get a little bigger here. Okay, address. What else do we need? So we need move 0 x1 this number here, and this number I just rewrote them here in hexadecimal, and I do not know why I cannot copy or mark this. So we're gonna copy this from here. This is the first number, so let me, for the moment, paste this here. So in arm64, we can obviously only get these 4 and then these 4. So the bottom 4 numbers are going to be 0x4e6d. And then we're gonna move, keep x1 0x41c6 with LSL 16. This should be fine, yes. So now the number supposedly, allegedly, is in x1. The next number that we're going to use is this one. This is the, can we see the preview here? This is going to be this one. So let's get this also. So move Z, we can just do move, and now we're going to do this x2. Put it here. That's also an immediate. That's the second value. I think we're gonna call now the mod function. No. Well, let me see the formula. Oh, we need to multiply all of this and then have this and then just call the mod function. Okay, so we also need what we can actually take. Let's multiply x0 with x2, and we don't need to, we need x0, so let me store. Let me subtract here from the stack pointer 16, and then we're going to store this address, store x0 on the local stack frame. So fp minus 16, or we can use minus 8. So just when we call the function, that we can then at the end, when we have our new value, store it back in memory. Okay, so we have our value in x0. Now we are overriding it because I'm multiplying it with x1. That's what we want to do. And then we're going to add to it x2. So now this all should be right here. And that's x0. And in x1 we now need so x1 we need the max value, so we're going to copy this from here as well. So let's do 1, 2, 3, 4, and this one as well. So we're going to do 0x fff. Move keep x1 0x7 fff. And left shift left this by 16. We should step through this in a moment. Let me delete this also. I'm gonna add here these values just so we know what they are. Oops, this should be this one. Whoa, whoa, whoa. We gotta get one more game, man. And here, this is the we're gonna do, where's the int max? This is int max. So the int max is, we're not gonna go into pseudo random number generation. We're talking about a snake game. Okay, so here's our stuff in x0 and x1, supposedly. And now we just call our modulo function. I think that was what it's called, 0 and x1. Okay. And now if we are lucky, the result is in x0. And we are returning that result. No, we're going to store that result. We're going to store x0 in okay, now we're going to need here ldr_x1. We need fp minus 8, and now we're going to store x0 at x8. Modulo function, unrecognized instruction, you want a branch label. Okay, let's first check if we're crashing. I think we cannot crash because we are not calling our function, do we? So we're gonna go to start and we're gonna go here. What do you want from me? Snake is up to date. We are not enabling raw mode. enable cook mode. Now we are doing some weird stuff here. Okay. Generate pseudo random number. So that's at least where our error is. So let's immediately check. No, before we check, I'm not gonna fall for this anymore. That's the zero check now. So right about here, and no segmentation fault anymore. So now we can step through it with confidence. Generate pseudo random number, break LLDB snake, break set minus address. We're gonna do this here. So now, where are we? Stack pointer, register read x0. That's the random number, and there should be something there. X64xp. So here is something. That's our seed. Do I have the address or the value? I have to check that one because here I have the address. The address is stored. And now we're gonna load here x0, x0, right? So that we get the value, not the address of the value. And I'm running this immediately. Object dump minus d snake, generate pseudo random number, LLDB snake, break set minus address here. So where am I? We're gonna go here. We have the random number, we store it, and now we load it. And that's our seeding random number, whatever that is. So now let's see register read x1. There is something in. Now we're gonna do this, and now we should have 41C64D, 41C64E6D, 4E6D. So there's our x1. Let's register read x2. 3309, that's also here. So we are multiplying register read x0, or whatever that is. And now we are adding it, register read x0, some big number, register read x1. We're not finished, job not finished. So here's the value. I'm gonna try to go next, register read x0. And there's our new pseudo random number, supposedly. So now we are not storing it, do we? Oh, maybe, let me go further. Oh yeah, there we are. So let us go check. Here's our random number. We're gonna load it, 29FC, that's what I'm gonna remember. So now 0554, register read x0, 0554, it's all here. So now we have a new number. As it should be random, any mistake would actually be to our advantage here. Or maybe not, but you know what I'm getting at. So we have the generated pseudo random number. Now we are needing a number in the range of the width and the height to create the food at the end for the table. So let's go to our next function, which is gonna be get random number in range. I'm gonna jack it, we're gonna end it, we're gonna not forget the pound, and what the bingo card is now is a 50-50. SP minus 16, I almost forget it, like not this time. SP goes there, SP, FP, LDP, fplr stack pointer and restore the stack and return. So get random number gets, in x0 we will get lower bound and x1 is gonna be the upper bound. I'm just like typing. I'm talking, I'm not looking in the camera. Cheers. So we have real green juice, no green smoothie. So we have x0 the lower bound, x1 the upper bound. We are now generated a pseudo random number, and we're gonna call that, and then we have to get our modulo in range function. Right, so we're gonna store package x0 and x1 on fp minus 16. So everything is good. We should have them now. Do I want to have them individually? I don't need them individually. Stack pointer is now adjusted. No, it's not, because I did not do this. So now the stack pointer is adjusted. So we create 16 bytes on the stack pointer and push x0 and x1. And now the first thing we're gonna do is generate pseudo random number. And why is that? Okay, pseudo random number. And this should populate our random number in memory. And we need that for our range function. We're going to load that ldr x0. What's the, oh, we need the address first. So address page x1 random number at page at x1 random number page off. We're gonna load x1 the number. That's a 16-bit number, so this should be fine. Is it? What am I doing? Random number space. Okay, yeah, that's a big number. So let's go back here. So we have now supposedly the random number in x0. We want in x1 the lower bound. So we're going to use the frame pointer, and I'm going to use this one. Let me think 1 second. This is going to push minus 16 and place x0 there. So x0 will be on minus 16, will be the lower bound. And on x8 will be the upper bound. And then we're going to call modulo range. And then we have our result in x0, and that stays in x0, and get random number in range will return that from x0. Okay, so let's test it. Where are we? Why are we? What am I? So, we're gonna place move in x0 some value 1. I'm gonna move in x1. Gonna 17. And we're going to say branch label get random number in range. And then we have the result in x0, and I'm going to comment this out. So we're going to generate it. And we're in an endless loop. Are we? Okay, general when that happens means I forgot the return. No, I did not. We call modulo range. How do we end up here? Get number in range. Maybe, well now it's working. Well, maybe the computer was just slow. So let's call, oh no, it compiles, it just doesn't run. Okay, so object dump, get random number in range. Stack pointer fp. We are changing the stack pointer, that doesn't matter. We are moving the frame pointer back here. This should be fine. fplr stack pushing. So let's just do it. Object dump minus d snake, get random number in range. So get this, LLDB snake, break set minus address there. Oh. So let me get the stack pointer. This is here, let me check the stack. x128 xp. So we are there. This is up though, minus 128. So we have the stack here. We're gonna step, and we're gonna step, register read SP, 2E0. So now the stack pointer is here. There are our values. Wire stop it. Frame select. Okay, now we are register read x0. This is a 1. Register read x1. This is a lower bound, upper bound. We are going here. Where is the stack pointer here? 11 and 1, they are both here. Register read SP. This is E0. E0 is here. The stack pointer is not aligned. That's because I didn't use the stack pointer. And that's clear why it crashes. Okay, now it runs. So let us see what it returns. 12. 2, looks good. Looking good. Another 2, looking not good. An 8, looking good again. Run it. An 8, always twice. Don't like it. An 8. A 14. A 4. Okay, another 4. A 10. A 15. Okay, I think we are in the game. So we have a random number in range. I just assume that works right now. And if it doesn't, we fix it later. Good. So we have the random number, get random number in range. Game loop, enable cooked mode. What do I want to do? Yeah, now it's time to, we can generate numbers, but we have to place the food on the table. Oh, do I remember the, okay. Okay, let's do get number in range. We are here, so now let's place enable raw mode. Oh, I should check that where I place it, but now enable cooked mode. That is all auxiliary stuff. So let's go to actual snake stuff. So that's somewhere, clear the screen. Initialize the playing field. So there we are closer, we are initializing the snake. We print the playing field, we move the snake. Before I move the snake, here I'm gonna go and say, put food on the table. That's gonna be the function. and we're gonna end it. So let's do the function stuff to stack pointer fplr, comma sp minus 16, bang, move the frame point, stack pointer in the frame pointer, then reverse the action, ldp fplr into sp, and readjust here, and we return. Okay, so until now we have a random, we have one random number, and we can generate them. And now with the getInRange function, we can generate a smaller number with the help of the bigger generated function in the between 1 and height minus 1 and between width between 1 and width minus 1. So now we're gonna place this in memory somewhere. And this is going to be, I think I placed this here. Yeah. So let's say we have food, and this is bytes. Well, wrong. Food, colon, dot, byte, and a 0. So this should be, no, we need 2, an x and a y for the food. That's what we want. Put food on the table. So the first thing is you're gonna get the address. Address page x0. Is that really the first thing we want? Put food on the table. It's not gonna get any input. You just have to call the function twice and then place it on the table at the end. No, we don't need the food coordinate right now. So what we do need, no, we don't need that. So let's branch label call generate random number. So now the random number in memory will be different, and now we're gonna move 1.
Sorry. If I had, oh, like I don't have any cigarettes on me now.
If I have x1, and now we're gonna do minus 1.
This is empty. There's nothing in here.
We're gonna move 1 in and width minus 1 in x1, and generate. What are we doing? What was the function? So I'm like distracted at the moment. So let me
Come back around maybe like an hour. Maybe
random
get some cigarettes. I might need that trade. Maybe.
in range. In
I
range.
got like 50 grinders, but you could always use more.
Get number in range, upper bound, lower bound. So I don't know why I'm.
I got like 50 grinders, but like whenever, yeah, I got mad grinders. But
Okay,
that's
so
why, 'cause I keep getting more.
get
Yeah, why not? But
number
yeah,
in
if you come back, I'll
range.
I don't care about
Get random number, huh? Random number in range. Good. So now in x0 should be the random number. So I'm going to store them on the local stack frame. So subtract from sp16, and then we're going to store x0 on fp minus 8. So this is width, so this is x food number. And we are not going to be concerned now that the food is not in the body of the snake. This is a problem, but we will do that in the next part when we are also going to do the hit detection, because the function is pretty much the same. So at the moment we are only generating x and y food. So we're going to do x food coordinate. This is going to be on the -8. Then I'm going to copy all of this over. I'm going to call the generate function again to have more variety here. And then we're going to do it for the height. -1, get random number in range. And do we want to even store that? That's probably not necessary. Well, it depends. We need the y coordinate first. So, oh yeah, we need the y coordinate now. But we need the y coordinate. Now we're going to store the values. So let me store address page x0. Now let's do x2, 1, 2, x2, food, add page, and then we're going to do add x2, x2, add page off. So now we have the address of our food, and we're going to store the y coordinate, and I do not enjoy that. So let us change that. Width, height. I might change this back and forth. Just wait a moment. So this is a v. This is width. This is the x now. So now we have the x coordinate in x0. So we're going to move byte. Oh, I wanted to change that. W0 into x2 with an offset of 0. That should now store the x coordinate of the food, and now we're gonna load our whatever load in x0 fp the -y coordinate. So we have the y coordinate in x0, and now we're moving the byte in, this is wrong, x2 and x2. No, wait. That's the address of food. Yeah, that's correct. Address of food, and here this is y, so this should be 1. So without trusting all of this, oh my goodness, what are we having here? Get random number in range. Get, branch label, that's number 1. Get random number in range. Branch, why don't I want to call branch right now? Let me check here my stuff. Are we running out? Are we good? We are all good. So, am I still? Did I mess my? No, that was my bag. So we are move byte W0. Move. Do we not need that? Oh, yeah. That's when you're mixing the two instructions there. LDR byte and load, not load, store byte, store byte. Where have I have the comma? 432G. So we have this eliminated. Get time of day. Call generate random number. Call. Yeah, we have no call. That is the weird part. Okay. Generate random number. Generate random number referenced. Generate random number. Okay. That is generate. This is not a word. Generate pseudo random number. Is that correct now? Yes. I don't know where I am. We're here and we're gonna do the same here. So good call. Check if we do not crash. So let's branch label, put food on the table. Object domain is the snake, so let's check this out right about here. LLDB snake, break set minus address. So we're here. I try to jump over this. We did 1, 2. Register read x0. Why is that a 0? Well, it could a 1. Well, let us go over this. Next, register read x0. It's still a 1. Next, 1, 2. Our register read x0, register read x1. This is the 31. We're gonna say, what we're gonna say next, register read x0, that's a 9, okay, whatever. We're gonna store that on the stack. Register read x2. That's now the interesting part. We have here our food, x64 xp. So there is, you should have store now our values. So the first is a 9. And the second is a 1. Okay, let's run this again. Step, I could have done this better. So let's actually, or we can just break here. Break s-a here, continue. I'm gonna check it. So db, run it again, continue, 13a, so we are seeming to do the right thing there. So where am I here? So supposedly here we have now x and y stored in food. That's a desperate thing here. We have stored x and y in our food variable. What we haven't done yet is put it on the table. So we have to use the formula with times y plus x again. So let's do this. With plus 1 times y plus x. And if I did this correctly, we have in v0 here the y coordinate. Because we loaded here, because we loaded LLDB. Let me get this. W0. And I hope this is not an endianness thing now, but this should still work. So we have the y coordinate now in v0, and now we're going to move in x1 because we need to do this here with immediates, with minus plus 1, and then we're going to say multiply x1 and x0. Well, we should have here only one value, right? So that's fine. And now we need to load again. So load into the x coordinate. And now we're going to add it right here. Add x1 and x2. So now we should have the offset from what we want is the screen buffer. Do I calculate here? We have here in food, in x2, let me place this here in x2. Let me do this in x3. Well, this is a little lots of changes. No, let's do it anyway. So we're placing this in x3. So this has to be a 3. This has to be a 3. And I'm overriding here the 2 anyways. So we're going to go here in 4. Oops, sorry, 4. And we're going to use here the x4. So now in x2 is still the coordinate of CLS, clear the screen, because that's always the first thing we get from the page, address page, without a page off derivative. So now we're going to add x5, we can just keep going here, x2, x5, x2, we want to need the screen buffer at page off, right? Because we need now to add the offset to the screen buffer address. So once we have that, we're gonna add x5, x4, 5 and x4. So now we have hopefully the position where we want to place our symbol. And now we're going to need the symbol food. So let's symbol food. And I don't know the values, so 0x, I think it's 0x2a. But we might have to look that up. Put food on the table. Let's go right here. And we have no immediate, so we're going to move in x6 the food, or symbol food, I think it is. Symbol food. Let me check that. Yes. And that's now going to be placed store byte v6 W6 on x5, simply on x5. Screen buffer. Okay. So this should place something on the table. Well, let's run it. Well, it doesn't do anything. Do we gonna step through it or are we gonna YOLO it? Let's try to YOLO it. So let's go to start. Where is our game loop? Somewhere here. Why I'm deleting this line by line, nobody knows. So I think I put it always here. So we're gonna place label. Put food, check in word. I'm gonna go here. I have this, do this, and have this. Okay, so YOLO. Or not. What happened? What happened? Undo. Redo. Save. Let's go. YOLO. And we have something, but it's completely wrong, and it's all in our line up there. And now we have a Segfault. All right, beautiful. It's generate pseudo random 1, get random number in range. So how is this even possible? So I'm gonna say we're gonna step through it. Object down -d snake. I have to keep a little bit an eye on the time, so get random number in range. Where is start we're gonna go to put food on the table. 1 second. What am I doing there?
Come on now. Draw. Hey, Red, draw, man. Ain't something here now.
Get random number and range. Let's delete that. We do not need that. I don't think. Well, that won't cause the problem. That's not a thing. And let's remove that here.
Kept talking.
So let's go. And that's the same thing here. Okay, so make, let me get this, make object dump minus the snake. So put food on the table is here, LLDB, break set minus address is here. Hello? So this should be the first time we are calling it. So we're generating a random number. We're having this generate number. Okay, yeah, that's fine. We don't need that. Oops. We're gonna overwrite that immediately. And now get a number in range. So that's a 2. That's a reasonable number. Store it on the stack frame. Go another one. Do this, register read x0 and 2D. So we have, I don't remember, 2 and 2D, I think. So now this is our stack frame. We are getting our food, register read x5. Was it x5? Register read x5. No, register read. Well, let me check. Put food on the table. So we store the food is here in x3. Register read x3. So that's the food. Let's check it out. 64 XP. Well, that's nothing. So let's check it out here. It's 0, 0. That's obviously not correct. Why is it 0, 0? So we are loading. Well, it's 0, 0. Well, at least we now know where we now know why we are in the top lane, because it starts with 0 and it probably never gets out of there. So let us check out why. We have time of day, we seed the random number, we generate the pseudo random number. So let's go to put this number back in.
Get out of here, Reggie. You ain't win that game. You gotta at least drop that. Come on.
So put food on the table.
You want it? Let's go. I beat you in the first game. You ain't beat me that second game. You got up. You got up to go make some money, right? You fucked with the piece. Cause I'm thinking you about to make some money to help you out. I'm thinking y'all about to play.
Put food on the table. So we're gonna go here and we're gonna check out the food. Generate pseudo random number. We're gonna go here. Where are we? Where is everything? Let us step a little more. Because I do not have any of the addresses right now. So we're gonna start here at get time of day, check where everything is, and go through it one time. Object dump, no, LLDB, snake, break set minus address. Get time of day, so we are here. Register read x0, that's time of day. x64 XP. So step. So now that's still working. So we have this. Now we're going to seed the random number, which is just a copy. I'm going to jump over this, break set minus address here, continue. I'm going to check this out, and there is a 0 in the seconds. Is that important? Not really. Okay, that's not the issue. I'm in the copy struct loop. No, get me out of this here. Oh. Copy break set minus A here, continue. So we are here. Okay. Now we're going to generate a pseudo random number. Register read x0, random number. That's the real important address. x64xb. A3. Okay, so we're going to do our stuff here. I'm going to call the modulo function. And we haven't stored it yet. Register read x0, that's the number. Register read x1. So that's the random number. And now here is our... Do we store the right thing here? A3. Register read x0. Yeah, that's the random number. Okay. So get random number in range. Were we there? We were not there. Okay, no. We just returned from generate. And now we put the food on the table. So let's call it. We are generating a new random number, so let's check it out. This is here. So we're going to call next. So now we have a new number here. This is fine. I'm gonna place this here for the moment. This is fine. So now we have get random number in range. We are using this completely wrong. So get random number in range needs the number in x0 and then the range in x1 and x2. No. That's modulo range. I'm stupid. So let's keep on going. We have 1 and 4. Register read x0. Register read x1. That's the range. So we're going to go random number in range. Generate another one here. Register read x0. A new random number. Get random number in range. Generate pseudo random number. Does that store? One second here. Get random number in range. What am I doing here? We are calling generate pseudo random number, which does change the number in memory as well, right? So that's fine. Okay. So we are here. Register read x1. Register read x1. So this is random number. Register read x0. That's an we are getting the number now in x0 right now. This should be the new random number. And get random number in range. Okay, what am I doing here? Get random number in range. Where do we store this? And now we're just placing it in the range. It's fine. So Here we get register read x1, that's the one. Register read x2 is the thing, and register read x0 is the number. Now we're going to call modulo range. Register read x0, that's nothing. And copy struct. Branch modulo range. Were we not just there? And copy struct loop. Branch modulo range. Where is this function? That's okay. I lost track of the plot right here. Modulo range was here. 1994, we're here. So what was in x0 though? Register read x0. Why is here now terminus raw? Modulo range. X0. So let's get random number range. Let me get there one more time. You check the time. Yeah, that's all fine. Put food generate certain render. This is within this function here. So we go here, LLDB snake, break set minus a. Gonna break here. I'm gonna call this. You're gonna generate a pseudo random number. Step register read x0. Get random number in range of, okay, register read x1, that's the range. Now we're going to call this register read x0. That's the number. Register read x1. That's now the address. We are generating it and we're loading it. That's not necessary. Nevertheless, we have a number and it's even the same number, so we can skip that whole part. Okay, so this is fine. x1 is 1. That's also fine. Register read x2. Register read x2. That's also fine. Register read x0. Okay, now we go next. Why are you not breaking there? Okay, put food on the table, generate food, random number. Or ended up here. I didn't want to end up here. Run it again. We didn't jump over it. Next. And next, register read x0. That's an E. So, okay. Where is this? Register read x3. That's the food. So let's go there. x32, x or 64, so we can see better. Here. So there is now a 0. So there's obviously something overwriting this, right? What is before food? Random number space. Oh, I know. No, I don't know. A random number. Let's go to copy struct. No, this is an 8. We are copying the 8 here. This should be fine. So why is food random number store x0 on the stack frame? That's alright here, random number. When do we store? We are loading here something. We are loading, get loading.
I'm just pissed now. So if I catch
Get random number in range. So that's fine. Where is the put food on the table? Store, move,
chess, anybody, chess.
store byte. So this is also. Here we should destroy the food. So I'm not quite sure why. So register read x3, that's food. Register read w0, that's the E. So let's just check it out. So here, oops, here's the E, that's fine. Register read v0, that's the 6. That's the 6E, that's all okay. W4, that's an E. Step, register read x1, that's the width. Register read x1, that's a big enough number. Register read x1, 140, add whatever. Register read x5, that's the screen buffer. Register read x5, screen buffer plus 14. Well, 14 is going to be in the 0th row. Screen buffer. Why are we in the 0th row? That's not good. Let me. Width plus 1 is here. So even if y is multiply x1 with x0 here, this should never be under 50. x4, this makes no sense. Because we have width and the y is between 1 and 5 with height minus 1. So that means we can never be under 1 times width, right? So this makes no sense here. So let's run through this here again. Step next, step next, step next, step, register read x3. This is this.
You can't look. Don't look.
Register read x1. This is the width plus 1. Register read x0 is a 6. Okay, so register read x1 is a 132. Register read x4 is a 1A. Register read x1 is a big number. So now, why the 6? Step. Register read x1 is still this number. Step, register read x5. Screen buffer plus 26. Register read x0. So something I'm overriding right here. Screen buffer page off. X4 and x5. Register read x5. Register read x2. Register read x5. Screen buffer. Why is the screen buffer plus 26? Well, because we added 26, but it shouldn't be 26. With multiply 1 and x0.
missed it. You were one off. He was right the first time.
Step. Next step. Next step. Next. Maybe I'm focusing here on the wrong thing right now. Store. Register read FP. Let me check also this. This X 56 XB. This minus 28, whatever. No, not like 32 or something. So 1D and 6, these are the values. We can agree on that. That's okay. So now register read X2 is CLS. That's okay. Register read X3, address of food. Register read V0 is 1D. What did I say here? 1D is a value. So now we're storing it in food. That's correct. Now this is 1D. Register read V0. Now we have the 6. That's also correct. Now we should have everything in food. Where is the width plus 1? Okay. So here we have register read V0, W0, we have Y. And register read W4 is 1. Why is it 1? It should be 16. So I am not storing 16. One second. Store.
Wait, let him play.
Store X0. We're not. Something ain't right here. FP. One second here. I'm storing the random number on -8 for Y is on -8 and X is on -16. So we are loading X in W4. Why is it not in W4? Because we didn't load it yet. Register read W4. There's the 1D. Register read X0. Register read X4 is a 1D. Register read X0 and X1. These are the values. So now we have 51, the 50, or the 31. So we have 51 in X1. Register read X0. That's a 6. So now, where are we? Register read X1, frame select. Register read X1. That's the 50. So that's the 50. Register read X0. That's the 6. And now we do the multiplication. 6. Register read X1. That's 132. Reasonable number. Register read X4. Also this. 4 to X1. Register read X1 and 4. Add it. Step. Register read X1. Here's the value. And now we are adding X. Okay, yeah. We are adding. No. We are adding X1 to X5 to go in the screen buffer. What the hell did I do there? And now we have food everywhere. And this is a good thing because we can see if the random number generation is more or less okay. And that looks pretty evenly distributed. My goodness, what did I do? It's always these moments why the videos have to be can only contain what they can contain here. What time is it? All right, we seem to have a fairly evenly distributed value. So let's see, I have here the result in x1, the screen buffer is in x5. We're adding x5 to x1, and we could also store that in x1 and then go to x1. And since we do not need the x0 anymore, I'm also gonna go here and place this in x0 to fuck me over. So let's do that, and let's do that, and it's still working. All right, so we are here. So the next thing we need is obviously some variable to food where we say food is served. And we're gonna initialize that. It's like a true or false value. At the beginning we're gonna say it's false. And we're gonna say the food is not served. But now if we put food on the table, the first thing we're actually gonna do is load address page x0 food is served at page change in word x0 at page off. So now food is served, the address, so we're gonna load the value, load LDRB with W0 in W0, and now we're gonna compare byte W0 with the value 0, and the food is, or if it's true, if it's true, we're gonna branch. We're gonna say branch and put and put food on the table. Otherwise we're gonna do this, and at the end here, when everything is done, we're gonna also move a 1 in x0 or wherever now in x0. We don't need anything at this point though. We need the x2. We're gonna add x3 x2 food at page off. Well, here is hopefully the x2 is still. Did I overwrite this in my? Yeah, I did, right? Didn't I? That was x2 to x0. We don't use the x0. We have the x6. No, we are not. The x2 should still have the address. So now in x3 should again be the address of food. So now we don't even need that. We want food is served. And we're gonna store byte W0 in x3 and hope that's correct. So let's test that. Compare byte, yeah, that's not the thing here. Compare byte, this is just compare. Well, let's do that. Oh, there is nothing. Let me check. There is not. If there is no food, yeah, that's. I think I made it wrong. Put food on the table. If it's false, then we generate. Right? I initialize it with 0. If there's no food, then we're going through the control sequence and place a 1 at the end there. So let's do this. Still not. No food. So here, I think I messed this. This is, yeah, here we should now have food on the table. So let's go to the loop actually. Oh, it's getting cool. getting chilly here now. Object dump main is the snake. We check the camera. Here we are good. So let me check. Put food on the table right here, there, and go break LLDB snake break set minus address here. Here, step, put food on the table, register read x0. I think I'm in at wait, register read x0, that's food is served, so let's x32xb. So we have here a 0, so let's go here, register read w0, it's a 0, we compare it with 0, and we are branching to the end. Food is served is wait, I say it's not served at the beginning. Where is it? So yeah, this was if it's true. Right, how did I name this? Food is served. Yes, we have to say food is served has to be a 1. So right here, food is served, we should store 1 right about here after we did it and placed it on the thing. So let's check that. Why is it not here? So object dump minus the snake, put food on the table, LLDB snake break set minus a here. I'm gonna do this. No, we cannot have rain here. That's the one thing we cannot have. Why did I have this weird thing? Object dump minus the snake, put food on the table, write this address, LLDB snake break set minus address this. Okay, so here we are. Get the value right here, so it's 0. So we are not branching. Why are we branching? Register read x0. If food is served and put food on the table, it starts with 0. So I come LLDB snake. So let's go place it on the table. Register read W0. It's 0. We compared with 1. We are not. I have a thing. Oh. I saw it. I think I just branch. Compare branch not equal. Wait. If it's equal, that's now branch equal. If it's true that the food is served, we go to the end. Still nothing. Step. We have W0, register read W0. It's a 1. Why is it a 1? I know why it's a 1. Put food on the table. put food on the table because we're calling it here. So I don't want to do that for now. Still, this is a break. Oh no, now we changed the lines. Object dump minus the snake. Control snake, sleep function, put food on the table. My brain is done. LLDB snake, break set minus address this. Do it again and check it out. We're on the easiest. Where am I? Oh, we are in the thing. No, do it again. We are here. Subtract. Here we have now register read W0. It's a 0. There's a 1. Branch not equal register read W0. It starts with a 0. Is that false? No. If it is so how food is served. That's how I called this thing, right? Food is served is false. So let's see if it's false. No, we have here 1. If it's true, branch food is served, it's true. If it's equal to true, then we're gonna jump over the function. That's the idea. Well, there's food. There's still not more. Okay, a little. I'm just enjoying this right now. So we are at least once in the function. Object dump minus the snake. This is part of the thing. LLDB snake break set minus address here. So we are here, put food on the table. We have it at the beginning, it's no food on the table, we compare, and now we place it on the, oh no, I now am in the range function, in the generator here. In the modulo function, now we are looking at everything. Let's run it again. Put food on the table. We are in it, we are going next. Generate pseudo random number, we get the random number in range. Another one. So register read x3. That's whatever. Register read x3. That's the food. Let's check out if that's there. x32 xb. So food. Oh no, now we are storing the food. So now we have the food. Now we are placing it on the board. So now we have to check. Register read x6. Move. And now we are here. 1 second here. Let's. Where are we? We were here in x6. So do I have still the 1 second? Let me go. I'm in the wrong thing. Where is the x6? This is obviously not correct. So we want to go here. LLD break set minus address here. So continue. Register read x1. That's screen buffer. Okay, yeah, that's correct. So now we're gonna store it. And now we're gonna move 1 in x0, register read x0, that's fine, register read x2, that's the crucial one, that's CLS, register read x3, food is served, register read v0, food is served, and now this should be set to true. Oh yeah, I mean, I'm just an idiot. This is all correct. While I ran it, continue. So we are setting it. I was like, okay, and now register read x3, food is served. Let's investigate x32xb. Right here it's 0, do a step, and now there's a 1 and the food is served. So of course, if the food is served after eating it, it will not be longer there until we grow the snake and eat it. So that's the last step that we're going to do now. So this function seems to work now longer than we wanted, so more luck with the next one. And that is grow snake. We're gonna do the first thing now, and grow snake, the inverse of the food is served. We're gonna say if we have now the head pointer and we have the food address, we're gonna get the x coordinates, compare the x coordinates, and then the y coordinates. If they are both equal, then the food is eaten. So that's the whole idea now. Holy moly, holy cannoli. So let's go. Stack pointer stp fplr sp minus 16 and move fp stack pointer in the frame pointer, removing this here, the ldp fplr in sp 16, and we return. So what do we need to do? We need the head pointer and we need the food pointer. So address page, let's get food address x0 food add page, then add x0 food page off. We need as well add x1 x0 head add page off. That's the address, but what we really want is ldr x1, where it's pointing to. So we are getting this. So now we have in x1 the head and in x0 the food. And I wish that was the other way around. Can I do this? x1, this is x1, x0. So now we have x0, x0. No, still not. Ah, I'm so sorry. 1 second. The address is in x1. Now we put the head in x0. The real head here in x. And now we're going to put the food in x1. So that's correct. So now we have the food and we have the food and we have the head and we have the food. So now we get the x coordinate. So LDR byte in 1012, I get x0 0. That's the x of the head, and in 3 I'm gonna get the x of the food. compare byte, compare W2 and W3, and branch. When they are not equal, then there's nothing we're going to do. It's going to say end grow snake, and then we're going to load all of this again, but this time we're going to load the y coordinates and we're going to copy them again. So this should be, we get the x pointer, hopefully we get the pointer, we go to the coordinate buffer, we get the x and y of the head, and then we get the food x and y, compare x and compare y. So, and then when this is all true, then the head is the same as the food, and then we're going to do now add, is x1 still available, add x2, x1, the food is served. I know, wanted to do rip. Food is served at page off. So now we should have the address of food is served, and now we can move in x3, a 1, a 0, food is not served, it's false because we just ate it. So we're gonna store byte v3 in x2. Okay, a lot of stuff that won't work. So, okay, even worse, a comma. Comma gone. What else? Another STP comma. Why don't you tell it twice? Clear. Page FF, there's something missing. Oh. Page off. Why is it getting chilly now? And food page off. There is here. Okay. So let's run it. This is like, I'm still a hopeful person. Okay, so let's grow snake. We don't even call the function. Where is it? I remain hope. Control snake, move snake, branch snake. Why do I control after move? Grow snake. Where is my food? Okay, so now we can check it. I'm not a fan. Move, it doesn't matter. For now, make one last test, and now object dump minus the snake. Grow snake is here. LLDB snake, break set minus address here. State. We're gonna grow, and we're gonna get the head here. Let's check. Register read x0. This snake plus 8, that's where the head is, that's fine. Step, register read x1. That's the food address. Step, register read W2. That's 19. Register read W3. That's a 0. Okay, let's do this one more time. Let's see if now there's food. Register read W2. Register read W3. Now there's food. 64 hex. (64 hex). 1.16 gigawatts. What? 64. X64 XB. 13 and A, that should be there. Register read X1. Grow snake. What is there? Wait, am I frame select? Am I jumping the gun here? Get this here. Register read W2, register read W3. 13. Now this was fine. I just jumped the gun. Okay, 13 is X, and okay, and obviously we are just moving along now because we didn't eat it. So we need to do break, disable, continue, and go on collision course. Break, enable, continue. What was the last thing? We are still ahead, doesn't matter. We can still check. Register read W2, 13, and W3, 13. So we are checking the Y coordinates first. No, the X, that's fine. Compare, they're not equal. So we are going here, register read W2, A, and 3. Why are they the same now? Wait. What was the last state? They're not the same, they're off by 1. That's horrible. That's truly horrible. Why are they off by 1? So now they're already the same. Or we are already moved. Well, let's check. So they're not equal, so now we are getting this here. Register read X2. That's some weird address. I think this X2 is, here's X2 is changed here, there. So grow snake. What? Why do I have the 2 here? Oh, 1. Register read X1 is food. No, this is still fine. Oh no, this is not fine. We need... Well, you know what? I'm gonna not mess around with this. Address page X1 food is served at page. We're gonna load it right here. Food is served address page X1 F. Food is served. Not gonna mess around with that. I'm just gonna do it and have a Segfault. While I press something weird. Oh, we moved there, and the food, we are eating the food. Let me check this. I don't know what I pressed here. I pressed 7 keys at once. Okay, but this works. Okay. And there's one last thing, and that is, we're just now going to do one thing. We're going to get the tail pointer. We're going to subtract 2 from it, and store it back. So we're going to do this here. So it's even good that we have this here. So now I'm going to, where's the point? Address page X0 tail at page at X0 tail at page off. So we have tail page and tail page off, so we have the tail address, but now we need to load the actual value of the tail. That's correct. This will be the address of the coordinate buffer, and now we're gonna subtract 2 from it. I'm gonna do all in X0, like we're gonna subtract 2 from it, and we're gonna store X0 in X0. No, we're gonna store X0 in Okay, this doesn't work, so we cannot overwrite this. We need this here. So we can do this. x0 will be the tail. No, I need this in x1. I need the actual, the value. The address of the coordinate buffer is now in x0. That's where we're subtracting 2 from. And now we're going to store it back. And this is the tail, that's a whole pointer. Sub $. Come on now. Let's do this. So let's do this. And it's growing. We are growing. Oh. Okay. So this works. So now the only thing left for today is to make sure that this subtraction here is done modulo the buffer. So we are staying in our circular buffer. So how do we do that? We call modulo range. And for that, after the subtraction here, now in x2 is the value. So we're gonna, x1 has still, we're gonna do x2, x1 screen buffer at page off. So that's the beginning. Oh, let me think. We need that for the modulo range function. We need our value in x0, that which we have, but we need the screen buffer in x1, and we need the head in x2. So we're going to do this here, head at page off. So I do this here. This line has to be done before, so we do not overwrite x, because here we are overwriting x1. So now, that we are overwriting x1 is also bad. Can we do this x1 and x? Well, it doesn't matter because we are calling a function. For now, we're gonna maybe clean this up a little bit. Now we're gonna do the screen buffer, and we're gonna branch label modulo range. Modulo range. Now in x0 should be the value, and we are storing it. Head, where's head x1, comma. So let's try it. Segfault. That's not good. Okay. Now we have a segfault. That's beautiful. The moment we eat it, food is served. So do we need this here? Well, let me check this. Address tag, we get the tail. We get the tail address here. That's the real tail. I made the same mistake I just did before. We want this in x1, so we want this in something like x4 maybe. So we're gonna take x4, tail is now in x1, x0, tail value, x0 store, but head is 4 because this is the address we are getting our page off. Here is the screen buffer. Okay, x1 gets overwritten, x0 has the thing. So let's do this. And still a segfault. Food is served. Food is served. Screen buffer. Modulo range. Tail. This is the tail. This is 0. This should be fine. We are storing here something in x1. What is x1 at this point? This is the screen buffer. This is not correct, obviously. We want this to be the tail. So we're gonna do this here again, and then check it. Where's the food anyways? LLDB snake, run it, give it to me. So okay, register read x17. Where are we? In move snake, register read x17. Okay, maybe not. Maybe where's grow snake? Let's comment this out. Let's go here. So still here we are good. So our mistake is obviously there. So let's LL object down. Let's write it. Let's write it. Let's compile it. Let's object dump it. And grow snake is here. Well, this is here. And now we're gonna say LLDB snake break set minus address this. So we're gonna say this, but we are not growing. So we're gonna continue. Okay, now break disable. Continue. Okay. Continue.
Are you live streaming chess?
No.
Oh, what are you just regular streaming?
Yeah, no, I'm not even streaming. I'm just recording for work.
Oh, recording for work?
Yeah.
Oh, cool, man.
So we're gonna do this. And now you're gonna click it, break enabled, break enable. Okay, continue, continue, continue. We are on collision course. Okay, step. Let's check the head coordinates. Register read v2. Register read v3. We are not there yet. Now it's the time 2 and 3. They are the same. Bang, bang, bang. Same check. I did already press my 3 and 2. They are the same as well. So now we are here. So we get the tail. Register read x4. Register read x1. That's the tail. Register read x0. That's the snake. That's where the tail is. We are subtracting 2. Register read x0. We are fine. Register read x4. Register read x2. We have the head. Is this true? The head. Is this even true what I'm saying here? Food is served. Modulo range. 0 is the value. 1 is the lower bound and x2 is the upper bound. Upper bound is head, that's correct. So, but we have the address of head, not. So we have to do LDR x2 x2. So we get not the address of the head pointer, but the address of the coordinate. Well, let's try this. Why? we're still in move snake. So so let me object dump minus the snake. So let's now go to really grow snake. This is the modulo range. So we want to be somewhere here. LLDB snake, break set minus address. We're gonna go here. Bang, and here we are. Step, 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 register read x0. That's the stake we are subtracting. Register read x2, register read x2, snake 84. That's the head. Head. No, of course we want the address of the head. What am I talking? We are using the head as the end address. And screen buffer, we also want the address. This was nonsense that I said. And let me think about this. We are having the tail. Wait a second. The tail. We have the address where we store the tail point, and then we get the value of the tail where the tail is pointing. We are subtracting. We have the stream buffer, we have the head, we have the value. This is all good. No, this is fine. So we have not the address, we have the value in x0. Let me check here. Where is modulo range? Modulo range. x0 gets the value, x1 gets the lower bound, and x2 gets the upper bound. So I am not quite sure. x2 has the, let's run it again. So we are here. I'm also concerned that we are seemingly breaking one early, but this can be. Register read x0. That's the tail value. It's not the tail value. We don't want this. No, the value at the tail. This is okay. This is the value. This is the value of the tail pointer. This is what we want to subtract. Yes. LLDB snake break set minus a. And grow snake step. So slowly. Register read x1. That's where the tail is. Register read x0. Now we have the snake plus 62. We are subtracting 2. What? Why are we now at... Did we not do anything? Register read x0, snake plus 62. Register read x0, register read x1, screen buffer. Oh my fucking god. Not the screen buffer. This is the coordinates. So that's why I should really do this with nodes. Now we're growing. We're not growing. Why are we not growing? Because I don't know. We have the value. We store x. We subtract it. We now modulo. We have x0 and x1. Well, let's wait. You did too much right now. So why are we not growing? Subtract. Am I here? This is the tail pointer. We have the value. We are subtracting 2 from it. So x0 is probably destroyed right about here. So we need, do we have something here? I'm gonna make subtract SPSP 16 because it's necessary. And now we're gonna store here before we subtract it. But no, we want, this is also not true because I want the, I have the new object dump minus the snake because we want the value. Like, I'm sorry for this, but that's it when you are in the pork. So, modulo range and grow snake, no excuses. And grow snake, we want to branch, we want to break here. LLDB snake break set minus address. We're gonna do this. And we're gonna go here. We're gonna get the tail. This is snake plus 58. Oh, we already subtracted here. So now we're gonna jump modulo range. And now we have still the thing, that's fine. Register read x1. What is x1? This is not tail, obviously. x4 is also destroyed here. So we are going to store x1 fp minus 8. So I have this on the thing, the tail pointer, and we're gonna LDR x. Where do I store it? The tail address right here. So we're gonna store, we're gonna load in x1 fp minus 8. This should be fine. And we're growing. Okay. We have a growing snake. I'm like, that was some hard stuff here. Okay. We have a growing snake. Obviously, we don't have hit detection yet. But that's good. So let's check this here because we have on 8 whatever x1 is the tail. So let me put here on x4 on the 16 because I have this. That's tail. And then I could LDR here. Is this really better? x1 fp minus 16. And then we could remove this, right? If it doesn't work, we'll just undo it. We're growing, and the food's moving.
I'm about to go downtown, Lower East.
That's okay. So this is that. I'm gonna get rid of this. So all I did is we are calling here address page tail, stored it on the frame pointer, loaded from the frame pointer and added here. So that's fine. So next time we're gonna make sure that the food doesn't spawn within the snake, and that if the head hits another segment of the snake, that this is game over. And that will be the last part officially. Thank you for enduring this part. I hope you learned something and enjoy my struggle. Thank you so much for watching. See you in the next one.